I may have a thing or two to say about that. This panel suggests harvesting air into water, and it kind of works, though there are some twists to it. We can't live without water, and even though 70% of planet Earth is covered in water, many regions suffer from drought. This is because most of the water available is not drinkable, at least not immediately. It is possible to turn salty water from the oceans to fresh water, but that takes time and energy. Fun fact, using nothing but clean cloths, cups and pots, dirty water can be cleaned and made safe to drink. This works by taking advantage of capillary action, which is when liquids rise or fall in a small passage due to the surface tension and the attraction between the molecules of the liquid themselves and to those of the surface. By using the simple design shown on screen, dirty water can be filtered. For extra safety, you could repeat the process multiple times and boil the water afterward. So water is hydrogen and oxygen, and those gases are everywhere in the atmosphere. So why not turn them into water? Well, this already happens naturally. It's called dew, and you must have seen people in survival films use tops to collect water from the air. But what is described in this panel is a bit more advanced, using wind that powers a fan which blows air into underground chambers where it condenses into water. The idea is that the ground temperatures are cooler than the air, so water vapor will condense on the cool walls of the chamber, producing clean drinkable water. Theoretically that's okay, but there are some important points I want to address. The places which lack water resources like dry deserts and Saharas are also regions with very dry air, and the drier the air, the lower its dew point, meaning this method would struggle to produce meaningful amounts of water in arid regions where it's needed most. Precipitation in dry areas can be encouraged by spraying salts into clouds, which act as a nuclei to attract moisture, but that's an expensive technology that is difficult to use and control, and there are always concerns about reducing rainfall in neighboring places. Going back to the method in the panel, and if you remember what I said earlier, the ground needs to be colder than the air to allow condensations. Well, that's only true for half the day, because at nights air can be cooler than the ground, and even at days you would need to go much deeper than 2 meters to hope for some major temperature difference. Not to mention that radiated heat from water condensation will warm the soil and reduce efficiency. And then there is the issue of wind. I doubt a wind-powered fan would consistently blow enough air underground to make a real difference. Even in optimal conditions, a design like this might only collect about a liter of water per day, hardly enough to solve water scarcity. So while the idea is creative, it's not quite the game changer it's made out to be.